Good morning, class. We are looking at pre-calculus practice test number 3, covering chapters 5, 6, and 7. Chapter 5, trigonometric functions. Chapter 6, periodic functions. Chapter 7, trigonometric equations and identities. And here's a pledge that I expect everybody to read and follow for every exam. So here's chapter 5, trigonometric functions, and chapter 6, periodic functions. All right, let's get started with some information that are absolutely necessary. Angles and their measurements. Definition: vertex, line, and ray. A line is a straight one-dimensional path that extends indefinitely in both directions. A ray is a part of a line that begins at a specific endpoint and extends indefinitely in one direction. So both directions is a line, one direction is a ray. A vertex is a point where two lines, rays, or segments meet, commonly known as a corner. Initial side, terminal side, positive angle, counterclockwise, negative angle, clockwise. Initial side. The starting position of an angle, it is usually drawn along the positive x-axis on a coordinate plane. Terminal side. The position of the angle after it has been rotated from the initial side. Positive angle, CCW, short for counterclockwise, an angle formed by rotating the initial side in a counterclockwise direction. Negative angle, CW, an angle formed by rotating the initial side in a clockwise direction. So, counterclockwise rotation, positive direction. Here's the initial side, here's the terminal side, and if you look at the arrow, that gives us the positive direction, or CCW, or counterclockwise. On the other hand, this one, initial side, this one is the terminal side going this way. This was angle alpha, this is angle beta, here's the vertex. Clockwise rotation or negative angle. By the way, if the initial side and the terminal side are the same, ultimately the two angles are called coterminal. We're going to continue. Standard position, quadrant angles. Standard position. An angle is in standard position when its vertex is at the origin of the coordinate plane and its initial side lies along the positive x-axis. Quadrantal angles. Angles whose terminal sides lie on the x-axis or y-axis. These are multiples of 90 degrees, such as 0 degrees, 90 degrees, 180 degrees, 270 degrees. Or if you go a complete revolution, 2 pi or 360 degrees, that goes back to 0 degrees. So having said that, here's an example. This is the initial side. This is the terminal side. Theta is in standard position and theta is positive. Again, we have a standard position, but counterclockwise is positive, clockwise is negative, terminal side. Theta is in standard position, theta is negative. And of course, if you're looking at this example, the terminal side is along the negative side of the y-axis. Theta is an example of a quadrantal angle. What is a right angle? What is a straight angle? Right angle, that means 90 degrees. So here's the vertex, here's the initial side, here's the terminal side, right angle, 1/4 of a revolution, counterclockwise, 90 degrees. What about this one? Here's a straight line, here's the vertex, initial side, terminal side, straight angle, 1/2 of revolution, counterclockwise, 180 degrees, or pi radians. If the initial side and the terminal side, okay, it's a complete revolution along the positive side of the x-axis. This is a complete revolution. One revolution Counterclockwise means 360 degrees or 2 pi radians. We add a couple more things. D over 180 is R over pi. Remember, pi means 180 degrees. So if degrees are given, put it here and find the missing radians, and vice versa. If radians is given, you can put it here and find the missing degrees. 1 degree is 60 minutes, just that like a clock, and 1 minute is 60 seconds. Here's a circular motion. S is the arc length, is portion of the circumference, S equals r theta. And this sector, area of a sector, is a portion of the area of a circle, half of r squared theta. Angular speed is the total angle over total time, or 2 pi times RPM. This is revolutions per minute. It could be revolutions per second. Linear speed, V, is total distance over total time. So if we go in a circular motion, S, which is the arc length over T, and it becomes R over. We'll discuss this further as we come across them, obviously. So let's continue. We want to answer the following: convert 315 degrees to radians. Well, there are two ways to do that. One is that you put the 315 here and find the R. The other one is to multiply it by pi over 180. Please understand, pi and 180 are the same. Pi, radians, and 180. Because we want to change this to radian, pi over 180. This is the concept of a unit conversion. Otherwise, times 180 over pi. And so this is 45 times 4. This is 45 times 7. And it becomes 7 pi over 4. What about the next one? 9 pi over 4. As I said, you can put it into this equation of 180 over pi. The pi's cancel out, obviously. So 9 times 180 over 5. 180 is divisible by 5, becomes 36. The product is 324 degrees. To convert 3 radians to degrees, 3 times 180 over pi, it's 540 over pi. This is an exact answer, everybody. Pi is about 3.14159, and it continues indefinitely, and this is a rough estimate. What is the exact value of sine of 14 pi over 3? I want to remind you that all trigonometric functions, sine, cosine, tangent, cotangent, secant, cosecant, they are all periodic functions. A periodic function repeats its values at regular intervals. Trig functions are periodic, and k is an integer. The k that we are using, or sometimes n, even I in some instances, represents an integer. So the for sine, and therefore sine, cosine, secant, and cosecant, the period is 2 pi. Whereas for tangent and cotangent is just pi. Therefore, because this is larger than 2 pi, you can take multiples of 2 pi out and you get the same answer. Since 12 pi over 3 is 4 pi, and let's write that. This is the same as 4 pi. Then, and again, it is multiples of 2 pi. Okay, that's fine. It's the same as 2 pi over 3, and sine of 2 pi over 3. It's one of the common arcs we need to know. It's square root of 3 over 2. And by the way, 2 pi over 3, or 120 degrees. Some of the common arcs, I want to remind you that we need to be very comfortable with. Okay, are pi over 3, pi over 6, pi over 4. For example, in the case of pi over 4, so if we look at this point, which has coordinates x, comma, y, x represents cosine, y represents y. Sine and cosine are the same, square root of 2 over 2. Tan and cotangent are the same, 1, and cosecant and secant are the same, square root of 2. Okay, and you can look at the lecture for the others, but we'll discuss them as we come across them also. We're going to answer the following. We're going to name the quadrant that contains the terminal point of the arc t equals 2. Justify your answer. Reminding you, a circle centered at 0, 0, the origin has the equation x squared plus y squared equals r squared. When r is equal to 1, the name is unit circle, x squared plus y squared equals 1. So every point P comma, P has coordinates x comma y, x squared plus y squared is 1. Therefore, if you look at the quadrantal values, 1, 0, 0, 1, negative 1, 0, 0, negative 1, because it's a unit circle. Now, what's even interesting is that x is represented by cosine and y is represented by sine. If that is the case, for example, you can easily see this one is 0 degrees. So cosine of 0 must be 1, sine of 0 must be 0, cosine of pi over 2 must be 0, sine of pi over 2 must be 1, and so on. And we have x squared plus y squared equals 1. P has coordinates x comma y, where it's cosine t and sine t. Sine represents y, cosine represents x. And tangent is y over x or sine over cosine. Cotangent is the reciprocal of that, x over y or cosine over sine. Cosecant is 1 over sine or 1 over y. Secant is 1 over cosine or 1 over x. Bear in mind, because this is a unit circle, if you pick any point, just erase it. This point has coordinates cosine t, sine t, and r equals 1. And I hope you remember, cosine is the adjacent over the hypotenuse. Because the hypotenuse is 1, adjacent is the x coordinate. So it becomes x over 1. Whereas sine is the opposite over the hypotenuse. And the opposite is y over 1. Because the radius is 1, we just get y. But if the radius is not, it's just y over r. So that's a general statement. So having said that, reminding you of the following. Let me erase my work so it becomes easier to follow. So we have the unit circle. So this is, for example, located at 1, 0, as I mentioned, 0, 1, and so forth. And so this is the arc length. S is t units, and P has coordinates x comma y. Again, x is cosine, and y is sine. Okay. So furthermore, we know pi is about 3.14. Therefore, pi over 2 is half of that, 1.57. 3 pi over 2 about 4.71. 2 pi is almost 6.28. So where is this number t equals 2 radians? Well, in the first quadrant, t is between 0 and 1.7, 1.57, roughly. Second one, it's between pi over 2 and pi, which is 1.57 and 3.14, roughly. Third quadrant, between pi and 3 pi over 2, roughly 3.14 to 4.71. And the last one, between 3 pi over 2 and 2 pi, which means 4.71 and 6.28. So going back to number 2. Where is number 2? Somewhere here. Therefore, it belongs to quadrant 2 again. First quadrant, second, third, fourth quadrant again, as we have learned it in algebra. Now, find the exact value of cosecant of 11 pi over 2. Again, we just can take off multiples of 2 pi, because 2 pi is the period of the function. However, I want to remind you of a couple of things, and that is very important, something called a reference arc. And by the way, theta represents the angle. Theta prime represents the reference angle. Theta prime, everybody, depending upon the text, they may call it theta prime, theta sub r, theta bar. They all means the same thing, reference angle or reference arc. If we are in the first quadrant, and by definition, it is the acute angle between the terminal side and the x-axis. So having said that, in the first quadrant, the two are the same, theta and theta prime. In the second quadrant, if this is the terminal side connected to the x-axis, and this becomes the reference arc, therefore it's pi minus theta, because pi is larger than the angle theta. On the other hand, if you go to the third quadrant, the angle theta is larger, and this is the reference arc, so it's theta minus pi. And finally, in the fourth quadrant, 2 pi minus theta becomes the reference arc. So everybody understands what's going on. Now, this one, 8 pi over 2 means 4 pi multiples of 2 pi, and so it's the same as 3 pi over 2. Now, cosecant of 3 pi over 2, if you haven't memorized, it's 1 over sine of 3 pi over 2, and it's 1 over -1, and it becomes -1. As far as the reference arc is concerned, everybody, it's pi over 2, but if it's a quadrantal angle, it's something we should know. We will discuss that just in a moment in the next page. Okay, so those become common arcs that we should be familiar. All right, so find the exact value of the trig functions of quadrantal angles. And obviously, we start with 0 degrees. As you know, this is a unit circle. This has coordinates 1, 0. Remember, we have x, y. X is cosine and y is sine. If that is the case, that means sine of 0 must be 0, cosine of 0 must be 1. Okay, and I'm going to remind you, tangent is y over x, or sine over cosine. Cotangent is the reciprocal of that, x over y or cosine over sine. Cosecant is 1 over y or 1 over sine. Secant is 1 over x or 1 over cosine. In other words, all I need is these two, and the rest of them I can figure out in no time. So again, this represents sine, this represents cosine. So we're going to write sine of 0 is 0, cosine of 0 is 1. So the best way to remember this is by remembering the unit circle and knowing that this point has coordinates 1, 0. Now, obviously, tangent would be sine over cosine becomes 0. Cotangent is the reciprocal of sine. That 1 over 0 is undefined. Okay. Cosecant is 1 over sine. That means 1 over 0 undefined. And secant is 1 over cosine, 1 over 1 over 1. So the rest are the reciprocals. I'm going to assume nobody has any problem with that. You really have to know all of them, but more importantly, learn these two and you are fine with the rest of it. Let's look at the next one, pi over 2, also 90 degrees. As you know, clearly this point has coordinates 0, 1. Okay, so cosine must be 0, sine must be 1. So we say sine of pi over 2 is 1, cosine of pi over 2 must be 0. And as I mentioned, the rest follow. For example, tangent is sine over cosine. What is 1 over 0? We say undefined. Ultimately, we get to infinity or negative infinity, depending upon whether we come close to pi over 2 from the left or right. So if this is undefined, the rest of them are reciprocal. So this is the undefined, the rest of them are the reciprocal of those three. Let's look at the next one, pi. So pi over 180 degrees puts us right here with coordinates negative 1, 0. Negative 1 is the cosine, 0 is the sine. So we get sine of a pi is 0, cosine of pi must be negative 1. Again, the reciprocals. Tangent is sine over cosine. 0 over negative 1 is 0. If tangent is 0, the rest of them, as I mentioned, they just follow in the same manner. You really don't have to memorize them as long as you must understand those two simply from the unit circle. Finally, 3 pi over 2, which is also the same as 270 degrees. P has coordinates 0, comma, negative 1. Again, 0 is cosine, negative 1 is sine. So sine of 3 pi over 2 or 270 must be negative 1, whereas cosine must be 0. And so what is tangent? Tangent is sine over cosine, negative 1 over 0, again, undefined, and the rest of them follow as well. And if you happen to have multiples of those, okay, multiples of pi over 2, I mean, 3 pi over 2 is an odd multiple of that. You should be able to figure out sine, cosine, and the rest of it accordingly. So what I want to quickly add is the following. So sine of n pi becomes 0, where n is an integer. Cosine of 2n plus 1, that means an odd multiple of pi over 2 is also 0. So those are the things that become obvious as a result. Okay. Determine the length of arc of a circle and area of a sector formed by the central angle theta if theta is 1/2 radians and r is 10 meters. So here's a circle. Here's the center. If from the center you draw a couple of line segments that end up on the circle, the angle created is called the central angle. The portion covered on this circular path is called the arc length. This is called area of a sector. And so, as you know, the circumference is 2 pi r, and 2 pi represents a complete revolution of 2 pi or theta. So theta times r is the circumference. So what would be s or theta, whatever that one may be? We know the area of a circle is pi r squared. So we can say half of 2 pi r squared. Remember, 2 pi is the theta. So 1/2 theta times r squared, or 1/2 r squared theta. Believe it or not, this is the proof for the two. For the arc length, s equals r theta. And for the area of a sector, half of r squared theta. So having said that, in this case, theta is 1/2 radian, and it has to be in radians, and r is 10 meters. S is r theta. The product of the two is 5 meters. What about the area? Half of r squared theta, 1/2. R we said is 10 squared. This is 100. 1/2 and 1/2 is 1/4. 100 divided by 4, or 25 meters squared, the units of the area. Okay, what if the central angle is 60 degrees and R is 5 feet? The very first thing, this must be changed to radians. And as you, I believe, all know, this is power 3. So that's the first thing we have to go with. And S becomes R theta, the product of 5 and pi over 3, which is 5 pi over 3 units feet, precise answer. And then how many decimals? Whatever they ask us. It's very important to use proper units always, and however many decimals they ask you, just to be on the safe side. What about the area of a sector? Half of R squared theta. R is 5 and theta is pi over 3. This is 25. 25 pi in the numerator, 6 in the denominator. Again, exact answer. And then however many decimals results in 13.090 units of the area, square feet. Each wheel of a car with a radius of 15 inches makes 3 revolutions per second. 1, 2, 3. That's an angular speed. How fast is the car moving in mph, miles per hour? In other words, we want the linear velocity. And I'm going to remind you that 1 mile is 5,280 feet. So what's going on? We want to discuss the concept of a linear velocity versus angular velocity first. So in the case of a linear velocity, everybody, total distance over total time. So if we are going in a circular path, becomes arc length, S over T. Angular velocity is angle, theta over T. So we are going to write velocity, linear velocity is total distance, which is S over total time, which we call it T. Omega, that's the notation, okay? The Greek letter omega is used for angular velocity, total angle theta over total time T. Now, if it's given in RPM or RPS, remember, a complete revolution is how many radians? 2 pi radians. So then you have to multiply it by 2 pi. This may be in RPM or RPS, or even revolutions per hour. Revolutions per unit of time. M means minutes. So if it's given in that format, because each revolution is 2 pi, you have to multiply it by 2 pi. So having said that, what is the relationship between these two? All you have to do, so okay, velocity is S over T, and we know S is R theta. So let's replace the S with R theta and write it as R theta over T. Theta over T is omega, so V equals R omega. Okay, so that becomes fairly nice and easy. Now going back to the question, we're going to reread the question. So the radius is 15 inches. That means R is 15 inches. 3 revolutions per second, units of time. So 3 RPS, and V is missing. So that is translation of the question. As mentioned, omega is 2 pi RPM, in this case RPS. So 2 pi times whatever this number is 3. So that makes it 6 pi. And now it's radians per second instead of revolution. 3 revolutions per second becomes 6 pi because it has to be in radians, 6 pi radians per second. And we came up with V equals R omega. Okay, let's go with that. R is 15. Omega in radians per second is 6 pi. 6 times 15 is 90 pi. 90 pi. And since this is in inches, 90 pi inches per second precisely. 90 pi inches per second because of the units given. This was per second. This is a rough estimate. Again, how many decimals, whatever they ask. Now, we're going to go back to the question. We have the answer, but we have to write it. Okay, what does it mean in miles per hour? So we are going to write 90 pi, I want to go with exact, inches per second. We must somehow get to miles per hour. And we know, of course, 1 mile is 5,280 feet. So I want to discuss what is known as unit conversion. Unit conversion is the process of changing a measurement from one unit to another while keeping the same value. Therefore, we use conversion factors, fractions equal to 1 to multiply and cancel units correctly. Examples, length, meters to kilometers. We know 1,000 meters is 1 kilometer. Time, seconds, minutes. We know 60 seconds is 1 minute. In fact, we know 1 hour is 60 minutes. Therefore, because this is seconds, 1 hour is 3,600 seconds. So what this says, if you look at this one as an example, if I said 1 mile over 5,280 feet, this is equal to 1. Or if I said 5,280 feet over 1 mile, this is a unit conversion. This is absolutely correct. Both of them are correct. But we have to see which one we need to use. Remember, the result is that we want miles to be in the numerator. So you have to go with this one as an example. 1 mile, 5,280 feet. Okay. But this is in inches. We should know that 1 foot, we should know 1 foot is 12 inches. So if that is the case, in order to go from here to feet, 1 foot divided by 12 inches. Then 1 mile divided by 5,280 feet. And finally, seconds, okay? We want to go to hours, so we're going to say 3,600 seconds over 1 hour. Let me erase my work. So times 1 foot over 12 inches. Again, it is the same as 12 inches over 1 foot, but 12 inches over 1 foot can't cancel out the inches. Notice what happens right here. And that's the idea. Then we say 1 mile over 5,280 feet. So this one cancels. Then we say 3,600 seconds over 1 hour. Let me see what color I can use here. The seconds go away. And if you just look at the units and nothing else, in the numerator, we have nothing but miles. In the denominator, we don't have anything but hours. And that's what we want. Of course, now 90 pi times 1 times 1 times 3,600. And the bottom is 12 times 5280 times 1. So those are the numbers. And roughly with a couple of decimals, 16.065 miles per hour. This was about unit conversion. And I hope everybody is okay with that by now. If the length of an arc S is 50 inches in a circle with a radius of 6 inches, find the angle theta. This arc subtends. In other words, what is given? S is 50, R is 6, and theta is missing. Well, since S equals R theta, theta must be S over R. 50 over 6, 25 thirds, and it's in radians. What about the area? Area is 1/2 R squared theta. 1/2 R is 6 squared, and theta is 25 thirds. As you know, 2 times 3 equals 6. So I can go with 2 times 3 cancels out one of the exponents because we have 6 squared. That means 6 times 6. So 6 times 25, 150 inch squared is the final answer, everybody. Find linear velocity of a cylinder with a 2 feet radius that is spinning at 40 RPM, revolutions per minute. So what is given? Well, radius R is 2 feet, omega is 40 RPM. What are we looking for? Velocity V. So this is understanding the question, everybody. Omega is 2 pi times RPM. That means 2 pi times 40 or 80 pi radians per unit of time is minutes, RPM. 80 pi radians per minute. Also, V equals R omega. Anytime you have omega, that's the best course of action. The product of the two, 2 times 80 pi gives you precisely 160 pi. This is the exact answer. And again, using a calculator, however many decimals, always write your exact. So 502.65 units, always given back with proper units, everybody. Okay, feet per minute. Find the exact value of each of the remaining trigonometric functions of theta, given that tan theta is minus square root of 3 over 3 and sine theta is larger than 0. So what's going on? They have given us the value of tangent, and the fact that they are telling us sine theta is positive, they are telling us really about the quadrants. So we're going to figure out the quadrants, and accordingly, we know the sign positive or negative. And there are two ways to come up with the answer. You can go with the circle or identities. We will discuss the identities as well in a moment. But for now, the first thing I want to remind you is the following. In the first quadrant, again, this is a unit circle. That's why this is 1, 0, 0, 1. This is pi over 2, so on and so forth. A point P has coordinates x, comma, y. This is t or theta, depending upon the text that you're using. And so this, okay, again, the adjacent over hypotenuse, okay, that's cosine. That's why x is cosine and y is sine. In the first quadrant, every trigonometric function is positive. That means sine is positive, cosine positive, tangent is positive. And with those, sine, with it goes cosecant because it's the reciprocal of that. Cosine, secant, tangent, cotangent. So that's why we write the first three. So having said that, what happens in the second quadrant, and remember, x, comma, y. X is the cosine where y is the sine. So when we go to the second quadrant, the y remains positive. That means sine remains positive. The rest of them are negative. When I say the rest of them, I mean cosine and tangent. By the way, if sine is positive, so is cosecant. When we go with the third quadrant, x and y are both negative. So sine and cosine are both negative. However, tangent is the ratio of sine to cosine. Negative over negative makes it positive. That's why in the case of a tangent, as well as cotangent, therefore, the period is pi, not 2 pi. When we go to the fourth quadrant, we are on the right side. X is positive, so is cosine. And of course, with cosine goes secant. So we should know that all we have to remember is that x is positive on the right side, y is positive at top, and the rest of them follows still. So what's happening here? We know tangent is negative. If the tangent is negative, then it has to be in this quadrant, quadrant 2, or this quadrant, quadrant 4. They are telling us sine is positive. Sine is positive here in the first and second quadrant. So I hope you see that this is in common. So it makes it quadrant 2 automatically. Now, because tangent is y over x, so tangent is y over x, and we said it's quadrant 2, then y must be positive. Please understand this. Let me just write this 3 different ways. Minus square root of 3 over 3, negative square root of 3 over 3, positive square root of 3 over negative 3. They all mean the same thing. But you have to choose one of them that gives you proper values for x, y. And how do you choose it? Well, we decided it's in the second quadrant. In the second quadrant, x is negative and y is positive. So this one, the way you write it, you have to choose accordingly. So which one do you choose? You choose this one. Okay, so x squared plus y squared is r squared. For x squared plus y squared equals 1 for the unit circle, and x squared plus y squared is r squared when it's not a unit circle, when the radius is more than 1, just so everybody knows. And these are the formulas. Let me erase my work. X squared plus y squared is r squared. In that case, P, which has coordinates x, y, or a, b, sine is, remember, sine is y over r. In the case of a unit circle, because r is 1, all of them just they lose the denominator. I'm talking about the first two, okay? And the other ones r become 1. But when you're talking a general case, it's y over r, x over r, and so on. And tangent is y over x. Tangent. And we've decided it's square root of 3 over minus 3, which means x must be minus 3, y must be positive 3. That's why I wanted to go over this concept so everybody can follow that. All right, so we said x squared plus y squared equals r squared. We can find the r. So this is 9, this is 3. They add up to 12. And r becomes square root of 12, which is 4 times 3, and 4 comes out as 2, so 2 is square root of 3. And so remember, as long as we get sine, practically we are done. Sine is y over r. So square root of 3 over 2 square root of 3, and I hope you see it becomes 1/2. Cosine is x over r, or negative 3 over 2 square root of 3. And if you multiply, if you want to rationalize, you multiply by square root of 3 over square root of 3. I hope you see that this square root of 3 times square root of 3 is 3, and cancels out is 3. Okay. So we get minus square root of 3 over 2, and I'm going to write the rest of them. I'm going to leave it for you to finish off. All you have to do, we have the sine, we have the cosine from here, we have the tangent, and the other 3 are the reciprocals. This is the reciprocal of tangent, cosecant. If sine is 1/2, this must be the reciprocal too, and this one's the reciprocal of that. It has been rationalized. So I'm going to leave it for you to justify that. So that's pretty straightforward, everybody. By the way, theta happened to be 5 pi over 6. It is a common arc. The value indicates that tan of theta being minus square root of 3 over 3 and quadrant 2. You look at square root of 3 over 3. So I want to make sure that the methodology is this, everybody. When you have this one, you say, okay, tan of theta of reference arc. You always change it to positive, and this is a common arc, and reference arc becomes pi over 6. Okay, pi over 6. In the second quadrant, pi minus pi over 6 results in 5 pi over 6. That's how you come up with the answer. Now, we could also use identities. So I want to remind you how identities are developed. We are looking at a unit circle. A point has coordinates x comma y. X squared plus y squared is 1 in the case of a unit circle. And x represents cosine, y represents sine. So if I replace this with cosine, I get cosine squared theta plus sine squared theta must be 1. Famously, we use sine squared plus cosine squared equals 1. So that's very obvious. Now, this is a Pythagorean identity, and there are two more identities known as Pythagorean identities. So we are going to divide in order to get to new identities, we use old identities. In this case, we're going to divide both sides by cosine squared. When we do that, obviously, this becomes 1. Sine over cosine is tangent, so tan squared. 1 over cosine is secant, so it's secant squared. Therefore, tan squared plus 1 equals secant squared. This time, we're going to divide by sine squared. So this is the one that we are dividing. And when we do that, obviously, this becomes 1. Cosine over sine, cotangent, so this is cotangent squared. 1 over sine is cosecant, so this is cosecant squared. And therefore, we have proved 3 Pythagorean identities. Pythagorean identity, sine squared plus cosine squared is 1, tan squared plus 1 is secant squared, 1 plus cotangent squared is cosecant squared. The quotient identities have been discussed. Tan theta is sine over cosine, cotangent is cosine over sine. Reciprocal identity is cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent theta. Find the exact value of each of the remaining trigonometric functions of theta when we know secant is true and sine is negative. The reason they give two of them to help us find the quadrant and therefore the sine. Okay, so first and foremost, secant, which is 1 over cosine, is positive and sine is negative. That is given, everybody. Now, what quadrant would that be? Remember, we are saying cosine is positive and sine is negative. So that puts us in the 4th quadrant. And of course, cosine becomes 1/2. Now, it happened to be a common arc, and I hope you see that actually pi over 3 is the reference arc, just in case. And you can find the values from here. So this one, reference arc, is pi over 3 because cosine of pi over 3 is 1/2. And for this one, puts us in the 4th quadrant. 4th quadrant means 2 pi minus pi over 3, which is 5 pi over 3. So I want you to know that. But in any event, let's go. If it wasn't a common arc, how would we do that? Let's go with the identities. And sine squared plus cosine squared equals 1. Cosine is 1/2. It becomes 1/4. Subtracted from 1, you get 3/4. And sine is plus minus the square root of 3/4. Now, positive or negative, sine is negative, so minus square root of 3/4. Square root of 3 over square root of 4, which is 2. So sine theta is minus square root of 3 over 2 because it's in the fourth quadrant. The rest are easy. Cosecant is the reciprocal of this 1 over sine theta. So the reciprocal becomes minus 2 over square root of 3. If we want to rationalize, we have to multiply by square root of 3 over 3, square root of 3, and we get negative 2 square root of 3 over 3. We have secant and cosine. Let's go to tangent. Tangent is sine over cosine. So that means this over 1/2. It's a complex fraction. You can drop the 2. It's minus square root of 3. And cotangent is 1 over tangent, the reciprocal of this, 1 over tan, or 1 over minus square root of 3. I'm going to leave it for you to show that if you rationalize, meaning if you multiply by square root of 3 over 3, you get this answer. And here's the summary of those values. Sine is minus square root of 3 over 2, cosine is 1/2, tangent is minus square root of 3, cotangent minus square root of 3 over 3, cosecant negative 2 square root of 3 over 3, and secant equals 2. We want to simplify. Secant of power 4, because we want to, and these are common arcs, we should know the values. Because this is secant, we're going to go to cosine because supposedly we have memorized the values for cosine. So 1 over cosine of power 4. A cosine of power 4 is square root of 2 over 2. Cotangent of power 4, just like tangent, is 1. And so this is 2 reciprocal, 2 over square root of 2, or simply square root of 2. We want to add these two. Remember, subtraction is a form of addition. In order to simplify, we want to add, we're going to start with LCD, and LCD is just a product of sine and cosine. So this will be this one times cosine theta minus this one times sine theta. Okay, let's do the distribution. Sine theta, cosine theta, or cosine theta, sine theta makes no difference. Plus cosine squared minus sine theta, cosine theta, plus sine squared. The numerator is cosine squared plus sine squared. Excuse me, which is equal to 1. 1 over sine theta, 1 over cosine theta means cosecant times secant, and that's the final answer. Cosecant theta, secant theta. I'm going to continue on that thoughts, and I hope you recognize you don't even have to move things, but let's move cosine squared next to sine squared. So we can see it's 1. And 1 plus cotangent squared is cosecant squared, is one of the Pythagorean identities. Cosine of power 6 times secant of 13 power 6. And this one is 12 power 6 over power 6, because 12 power 6 is 2 pi. You can get rid of it. Again, reminding you of trigonometric periodic functions, which is 2 pi for sine, cosine, secant, and cosecant, and pi for tangent and cotangent. So we do that, and as you know, secant is 1 over cosine, and therefore they cancel each other. They just give us 1. As I mentioned, in the case of cotangent, just like tangent, the period is pi, because we are adding or subtracting multiples of pi. it remains as cotangent theta. Does it matter minus pi or minus 10 pi or plus 10 pi? Same thing here. We have 3 of those, and the final answer is 3 cotangent theta.